Welcome back, dear children. Now we will continue with our numericals. So next is question number 5. A cell of EMF epsilon and internal resistance R. Okay. So we have a cell of EMF epsilon and internal resistance R. It sends a current of 1 ampere when it is connected to an external resistance of 1.9 ohm. So I is equal to 1 ampere if the external resistance is 1.9 ohm. Okay, but it sends a current of 0.5 ampere when it is connected to an external resistance of 3.9 ohm. Calculate the values of epsilon and R. So this is our question. What all things are given here? We have a cell with EMF epsilon and internal resistance R. Current will be 1 ampere if resistance, externally connected resistance is 1.9 ohm, and it will be 0.5 ampere if the externally connected resistance is 3.9 ohm. So we are asked to calculate epsilon and R. So how will we do this? So it's an indirect question. 2 different ways are given, and with that we have to calculate epsilon and R. And what you have to remember here is value of epsilon will be same, isn't it? Etra current or etra resistors ketiyalum, adinanusaриച്ച് current can vary, but the value of epsilon will remain as a constant. What is the equation for epsilon? Epsilon is equal to I into R plus R. Like epsilon is equal to V equal to IR. From there we are getting this. This is the equation. So now we are going to write this for these two sets of values. Epsilon will be same for resistor 1.9 ohm resistor connect cheyidalum 3.9 ohm resistor connect cheyidalum current will vary, but value of epsilon same aayirikkum. So what you can do? In the first case, the equation is 1 into externally connected resistance is 1.9 plus R. This will be equal to, what about the second case? In the second case, current is 0.5, then 3.9 is the externally connected resistance. Okay, so is it clear why I wrote like this? Standard form for epsilon is I into R plus R, and epsilon will be a constant. So if I write here, either epsilon is equal to 1 into 1.9 plus R. Here also epsilon is equal to 0.5 into 3.9 plus R. രണ്ട് side, since left hand side is same, you can equate the right hand side. Okay, so 1 into 1.9 is 1.9, 1 into R is R. Then 0.5 into 3.9. So 3.9 into 0.5, here the value is 1.95. Okay, I am writing it directly, not to waste time on doing it. So 1.95, you can just check, okay, plus 0.5 into R. I just removed the bracket. 1.9 plus R is equal to 0.5 into 3.9 is 1.95. 0.5 into R is 0.5 R. 0.5 R I am taking to this side, and 1.9 is taken to the other side. So R minus 0.5 R is equal to 1.95 minus 1.9. R means it is 1. 1 minus 0.5 is 0.5. 0.5 R is equal to 1.95 minus 1.9 is 0.05. So R will be 0.05 divided by 0.5. So when you are multiplying the numerator and denominator with 10, do it with 10. So here you will be getting 5. Sorry, do it with 100. So 5 divided by 50. That is 1 by 10, which is equal to 0.1 ohm. So internal resistance, we got the internal resistance as 0.1 ohm. Now you can give this value anywhere. And equations in the epsilon is equal to either 1 into 1.9 plus R, along this one. So since this is simple, 1 into 1.9 plus 0.1. This is 2. 1 into 2 is 2. So which is equal to 2 volt. Okay. So is it clear? Question number 6, 7 and 8 are direct questions. I'll put that in the Google Classroom. Okay. Now we will move to question number 9. 3 resistors, each of 2 ohm, are connected together so that their total resistance is 3 ohm. Draw a diagram to show this arrangement and check it by calculation. So, we are having 3 resistors of 2 ohm each. Now, these 3 resistors are connected such that the total resistance offered will be 3 ohm. 3 ohm total resistance, equivalent resistance കിട്ടുന്നത് പോലെ ഈ 3 resistors-നെയും connect ചെയ്യണം. So, how can we do that? If you are connecting all the 3 resistors in series, 2 plus 2 plus 2, you will be getting 6 ohm as the answer. പക്ഷെ നമുക്ക് വേണ്ടത് 3 ohm. ഇനി parallel ആണെങ്കിൽ, it will be 1 by 2 plus 1 by 2 plus 1 by 2. അരേ 1, 1 അരേ 1.5. 1, 1.5 means it will be 3 by 2. That is, total resistance will be 1.5. Adu alla vendadu. We need the answer as 3 ohm. So, if you are connecting all these 3 resistors in series or 3 resistors in parallel, you won't get the answer as 3 ohm. So, what is the next option? We have to take the combination, series and parallel. Okay. So, this is question number 9. I'm just taking one resistor. Then the next 2 resistors I'm connecting in parallel. Okay, now we will be getting the answer. So we have to check whether it is correct or not. This is R1, this is R2 and this is R3. So now this is a combination of resistors and we will check how to solve this. So if you get such a question, first thing is parallel ആയിട്ട് കിടക്കുന്നതിനെ അല്ലെങ്കിൽ കോമ്പിനേഷനിൽ കിടക്കുന്നതിനെ ഫസ്റ്റ് സോൾവ് ചെയ്യുക, പിന്നെ മറ്റേതുമായിട്ട് ചെയ്യുക. So here from where should I take? What you have to remember is these two, R2-ഉം R3-യും parallel ആണ്. Why? Because the ends are connected together. Okay. Then what about this one? This is in series with this. കാരണം ഇതിന്റെ പുറകെയാണ് ഇത് വന്നേക്കുന്നത്. So we are having series and parallel connection. So our first aim is you have to write R2 parallel to R3. Okay, both are parallel to each other. അങ്ങനെയാണെങ്കിൽ what will be their R equivalent? If 2 resistors are connected in parallel, I told you about an equation. What is that? R2 R3 plus R2 plus R3. Okay. So do you remember? If 2 resistors are connected in parallel, then equivalent resistance nu paranja 1 by R equivalent equal to R1 by R1 plus 1 by R2. Adu solve cheyumba kittunnathu endha? R1 R2 by R1 plus R2. Here since I have named it as R2 and R3, I wrote it as R2 R3 by R2 plus R3. Now, how much is the value? 2. All are of 2 ohm each, isn't it? So it is 4 by 4 which is equal to 1 ohm. അപ്പോൾ ഇത്രയും ഭാഗത്ത് വരുന്ന റെസിസ്റ്റൻസ് എന്ന് പറയുന്നത് 1 ohm ആണ്. So with that, let me redraw the circuit. This is our R1. This is the combination of R2 and R2 and R3, which is R equivalent. Okay. Now what will be the total resistance here? This is the connection. It's series connection. So R is equal to R1 plus R equivalent. Here it is not compulsory that you have to give R equivalent. If you want, you can give R4 അല്ലെങ്കിൽ R. Any value you can give. Okay. So 2 plus 2 which is equal to 4 ohm. Okay. So this is how you will solve the circuit. Sorry. 2 plus, what was the value here? It is 1. So you will be getting the answer as 3 ohm. This 2 ആണ്. R1, R2 and R3 were 2 ohm each. R equivalent, we got the value as 1. So we got the answer as 3 ohm. Okay. So this is how we will solve the circuit. ഒരു സൈഡിൽ നിന്ന് സ്റ്റാർട്ട് ചെയ്യുക, എന്നിട്ട് അതിനെ reduce ചെയ്ത് കൊണ്ടുവരിക. This time we don't have circuits with more than 4 resistors. So it will be easy to do. Okay. Okay, now we will move to question number 10. This is the circuit given. You can see two resistors connected in series with two resistors connected in parallel. So this is similar to the previous one. Only one change there. Only one resistor was connected in series. Here two resistors. Okay. So to make you thorough with this, I have taken the question. Now, first thing is we will name it. Okay. R1, R2, R3, R4. Name cheyana nirbandhonnuilla. It will be easy if you are doing this. So which part should I do first? First I will solve this. Okay. So you know that R3 is parallel to R4. Symbol for parallel. R3 parallel to R4. So what will be the resistance there? Here I took it as R. Okay. Total resistance R will be, since 2 is there, we have to use the equation R1 R2 by R1 plus R2. So 2 into 2 by 2 plus 2, which is equal to 1 ohm. Now how can I reduce the circuit? ഇവിടെ ഒരു ചേഞ്ചും ഇല്ല, അത് അതുപോലെ തന്നെ വെക്കുക. R1, R2, both are 2 ohm each. Here how much we are getting? 1 ohm. So this is R and it is 1 ohm. Okay. So I have redrawn the circuit. Solve ചെയ്തതിനെ ഇങ്ങനെ ആക്കി വെച്ചു. Now it's not compulsory to draw like this, but this will be easy when you solve the circuit. Now what about R1, R2 and R? Three resistors are connected in series. So what will be the equivalent resistance? Series connection aanengil total resistance will be the sum of the individual resistances. So it is 2 plus 1, which is equal to 5 ohm. Okay. So did you understand how to solve this? First complicated ആയിട്ട് കിടക്കുന്നതിനെ ചെയ്യുക. ഒരു എൻഡിൽ നിന്ന് നമ്മൾ സ്റ്റാർട്ട് ചെയ്യുക. ഇവിടെ രണ്ടും പാരലൽ ആയതുകൊണ്ട് we will be getting its value as 1. പിന്നെ വരയ്ക്കുമ്പോൾ all the three are in series. Okay. So is it clear? Now we will move to the next. Question number 11 is not there. Okay. You can just put a cut mark there. So I told you in the syllabus we don't have numericals with more than 4 resistors. So many resistors are coming there. So we don't want that. 11 is not there. Now question number 12. So the circuit is given here. And the total resistance of the circuit R equivalent is given as 4 ohm. And you are asked to calculate the value of X. Okay. So you can just look into the circuit. A and B are the two endpoints. Now from here you can see 2 resistors connected here and 2 here. 4 ohm and 8 ohm, X ohm and 5 ohm. Total resistance is 4 ohm. You are asked to calculate what is the value of X. Now can you tell me which all connections are coming here? Here we are having both series and parallel. 4 ohm and 8 ohm kudi nokkiye. One is connected after the other. That means 4 ohm and 8 ohm are connected in series. ഇത് രണ്ടും സീരീസില്. അതുപോലെ എക്സ് ഓമും 5 ഓമും സീരീസില്. അത് കഴിഞ്ഞിട്ട് ഈ രണ്ട് സെറ്റും കൂടി പാരലൽ ആയിട്ട്. ഓക്കെ. സോ ഫസ്റ്റ് തിങ് വി ആർ ഗോയിങ് ടു സോൾവ് ദിസ്. ഓക്കെ. സോ ഹിയർ ലെറ്റ് ഇറ്റ് ബി R1, R2, R3 and R4. R1 is in series with R2. So I can write, it will be R5. Okay. R1 is, or RA I will write. That will be easy. R1 ഉം R2 ഉം സീരീസിലാണ്. അതിന്റെ ടോട്ടൽ എന്ന് പറയുന്നത് I am considering it as RA. So since it is series connection, what will be the total resistance? It will be the sum of the individual resistances. So I got there 12 ohm. Now similarly R3 is in series with the R4. So let it be RB. RB is equal to X plus 5. Series ആയതുകൊണ്ട്. Now what will be the shape of the resistor? This is RA. This is RB. For RA, what is the value? 12 ohm. The A, the B. The 12 ohm. And this is X plus 5. Now, RA is in parallel to RA parallel to RB. So what will be our equivalent resistance? R equivalent is equal to RA RB by RA plus RB. That means RA RB 12 into X plus 5 divided by 12 plus X plus 5. Okay. Now 12 into X is 12X plus 12 into 5 is 60 divided by 12 plus 5 plus X. How much is 12 plus 5? It is 17. 17 plus X. Okay. Now I am going to wrap the top part. So R equivalent is already given. R equivalent, how much is given there? R equivalent is 4 ohm. So 4 into, I am just cross multiplying. 17 plus X is equal to 12X plus 60. Now how much is 4 into 17? 7. 4s are 28. Then 2 remainder. 4 into 1, 4. 5, 6. Isn't it? So 68 plus 4 into X is 4X. This is equal to 12X plus 60. 68 minus 60 is equal to 12X minus 4X. So 68 minus 60 is equal to 12X minus 4X, or what you can say, 68 minus 60 is 8, isn't it? 8 is equal to 8X. That means X is equal to 8 by 8, that is equal to 1 ohm. Okay. So what here you have to remember? Backly another, that is series connection. First solve that. After that solve the parallel connection. Then just cross multiply. Okay. So is it clear? Question number 13 is not needed since many resistors are coming. It is not there in the syllabus. Now question number 14 and 15, those are direct questions. So I will send it. Okay, I will send it through Google Classroom. Now question number 16 and 17 are also not needed since many resistors are there. Now we will move to question number 18. So here we are having four resistors. This point is given as A, this is B, C and D. So this is 2 ohm, 2 ohm, 2 ohm and 2 ohm. And two questions are given there. We are asked to calculate the equivalent resistance between the points A and B, A and C. Okay, so first one is to calculate the equivalent resistance between the points A and B. So A and B യുടെ ഇടയിലുള്ള equivalent resistance ആണെങ്കിൽ ഈ രണ്ട് പോയിന്റ്സിനെ നമ്മൾ ഇങ്ങനെ മാർക്ക് ചെയ്യാം. Okay, so we'll be considering like this. So ഇതിനപ്പുറത്തുള്ളത് സീരീസ്, ഇതുമായിട്ട് parallel. That is how it will come. So since 2 points A and B are given, A യുടെയും B യുടെയും ഒരു സൈഡിലുള്ളത് parallel. These are the two end points. ഇപ്പുറത്ത് വരുന്നത് ഒരു സൈഡ്, ഇത് പാരലലിന്റെ ഒരു സൈഡ്, ഇത് പാരലലിന്റെ സെക്കൻഡ് സൈഡ്. It will come like that. Okay, so when I solve, it will be clear. That is why I have marked A and B like this. So here also let this be R1, R2, R3 and R4. So in this case, since A and B are the end points, what you can say is R1 in series with R2 in series with R3. So what will be the resistance there? RA will be equal to 2 plus 2 plus 2, which is equal to 6 ohm. So the circuit will come like this. This point is A, this point is B, Here the resistor is of 6 ohm resistance, either 2 ohm. Now RA. This is RA. RA എന്ന് പറഞ്ഞ ഈ 3 resistors കൂടി ഒരെണ്ണമായിട്ട് മാറി, and that is RA. And RA is parallel to R4. So R equivalent will be equal to, how much is RA? 6. 6 into 2 by 6 plus 2. 6 into 2. I told you R1, R2 by R1 plus R2. So here it is 12 divided by 8. So it is 6 by 4 അല്ലെങ്കിൽ 3 by 2. 3 by 2 is 1.5 ohm. So 1.5 ohm is the total resistance between the points A and B. Okay. Now we have to calculate the equivalent resistance between the points A and C. So let me mark here A and C. ഇതാണ് endpoints. So what can you say? How will the circuit come? ഇത് രണ്ടുമാണ് endpoints എങ്കിൽ ഇതിനിപ്പുറത്ത് കിടക്കുന്നത് ഒരു സെറ്റ് ആണ്, ഇതിനിപ്പുറത്ത് കിടക്കുന്നത് വേറൊരു സെറ്റ്. Okay. So if I am marking, let this be R1, R2. This is how we marked, R3 and R4. Now, if you are considering the endpoints as AC, then R1 will be series with the R2, and so let me write it as RA. RA will be 2 plus 2, 4 ohm. Similarly, R3 ഇതാണ് endpoints ആയിട്ട് വരുന്നത്. അപ്പോൾ അതിനപ്പുറവും ഇപ്പുറവും കിടക്കുന്നത് സീരീസ്, അത് രണ്ടും കൂടി പാരലൽ. So R3 is in series with R4. So let me take it as RB. There also you will be getting 4 ohm. Ini, what will be the shape of the circuit? This is A, this is C. Okay. Now, it will come like this. AM, CM. Here it is 4 ohm. Here also it is 4 ohm. So our R equivalent will be equal to 4 into 4 by 4 plus 4. 4 into 4 is 16. 16 by 8, which is equal to 2 ohm. Okay. So when the points are given, you have to consider like this. അതാണ് end points. അപ്പോൾ ഇത് ഒന്നിനു പുറകെ ഒന്നായിട്ട് വന്നു. So series. ഇത് രണ്ടും അതുപോലെ ഒന്നിനു പുറകെ ഒന്നായിട്ട് വന്നുകൊണ്ട് ഇത് series. പിന്നെ അത് രണ്ടും കൂടി parallel connection. Okay. Now, here we completed question number 18. Question number 19 is not there in the syllabus. I am telling this because you have to mark it and keep. Then 20 and 21 I will send through Google Classroom. Okay. So in the next class we will discuss question number 22. Okay. So thank you children.